Hello, first topics of this video is real zeros of polynomial function, right? So let's say I have a polynomial function fx. So I have any polynomial function fx. Now for an example, let me write down a polynomial function fx. Let's say this is equals 3x square minus 7x plus 8. I'm just writing any polynomial function anyway. So what is the definition of zeros of a polynomial function? So we are interested in finding real zeros of a polynomial function. So let us see the definition. So let's say the zeros of a polynomial function is zeros of a polynomial function is the values of x, the values of x for which function of x equal to 0. So this is one definition. Also another definition, I can say the real zero of any polynomial function is basically the x-intercept. So x-intercepts are called zeros of that function. I wrote it wrongly. So zeros of the function. Okay, so this is the definition. So let us see for our example. So the zeros of zeros of this particular function is the values of x for which function of x equal to 0. So function of x equal to 0, and then you find what, 3x square minus 7x plus 8. Okay, now so find the values of x for which it is 0. So now as you can see how to find x. So x is equals minus 7 plus minus square root negative 7 square minus 4ac over 2a. Okay, so that's how you find the two values of x. Okay, so that is one way of finding. So this is also the real zeros. Now if I try to plot, like let's say any polynomial function, let's say I am plotting, let me use another color. Let's say I am plotting any polynomial function. So this is, let's say, the my polynomial function fx. Okay, so this is my polynomial function fx. Now what are the real zeros of this polynomial function? The x-intercept. So I have one x-intercept here, I have one x-intercept here, I have one x-intercept here. For example, let's say this value is x equal to 1. Let's say this point is at x equal to 4. Let's say this point is at x equal to negative 3. So how many real zeros I have for this polynomial? 3. One is x equal to 1, x equal to 4, x equal to 3. So real zeros are what? 1, 4, negative 3. So these are my zeros of this polynomial fx. Okay, so that is the definition of real zeros of a polynomial. So let us try to solve some problem. Okay, so let us see. So let's say I have, so find real zero for these two problem. One is what? Function of x equals x power 4 minus 2x cube minus 3x square. Okay, so this is the first problem, and for the second problem, find the real zeros of this polynomial, which is what? Function of gx equals x cube minus 2x square plus x minus 2. So these are my two problems. So let us try to solve one by one. So as we know that to find the real zeros of the polynomial, I have to equate what? I have to equate function of x equal to 0. So if I equate 0, so 0 will be what? Equals x power 4 minus 2x cube minus 3x square. All right, so let me write 0 here equals, so I have as you can see, I have x power 4, 2x cube, 3x square. So from this, all these three terms, I can take what? X square as a common term. So let me take x square as a common term, and what I am left with? I am left with x square from the first term, and from the second term I am left with negative 2x, and the third term I am left with negative 3. So this is basically my one. Now if you notice one thing here, this is what I have multiplication of two mathematical expression, and the multiplication equal to 0. So what can I write? I can write the first one x square equal to 0, and or the second one is what? X square minus 2x minus 3 equal to 0. So if x square equal to 0, I can say x equal to 0. So this is one real zero, or the solution. And the second one, as you can see, this is what? A quadratic equation. Now you can solve a quadratic equation by factoring or by quadratic formula, whatever method you use. So let me use factoring. So it will be x minus 3 x plus 1 equals 0. And again, what I have? I have two mathematical expression in product form, and product is equal to 0. So I can write x minus 3 equals 0, and or x plus 1 is equal 0. So I have x equals 3. Here I have x equals negative 1. So how many real zeros I have? So my real zeros for this polynomial is what? 0, 3, negative 1. So this is the answer. This is the real zeros for this particular polynomial. All right, so let us now look at the second polynomial. Now again, I am going to equate what? I'm going to equate gx equal to 0 to find out the zeros. So my polynomial is x cube minus 2x square plus x minus 2. So now as you can see, in this case I have how many terms? I have 4 terms: x cube, negative 2x square plus x minus 2. Okay, now let me try to, I'm going to try to factor it, and I'm going to first try with these two term first. Okay, these two term and these two term as a group. If it works, fine. If it do not work, I'm going to use the first and the third one, and second and the fourth one. So let's try these two. Okay, from these two term I can take x square as common. So x square as common, so what I am left with? X minus 2. And out of these two term there is nothing common, only 1. So let me take plus 1 common term, and I am having x minus 2. Now if you notice, I have x minus 2 and x minus 2 common in the both one. So I can write x minus 2, then what, x square plus 1. So x square plus 1, so which is equal to 0. So what can I write? I can write x minus 2 equal to 0, and I can write x square plus 1 is equal to 0. So I can write x equal to 2. So this is one real 0 solution. Here what I get, x square equals negative 1. So x equals plus minus square root negative 1, which is equals plus minus I. Now if you notice, this is not a real solution, this is what, a imaginary. So for this problem, what are my real zeros? So real zeros for this problem is only 1, which is 2. Okay, so that is the solution for this particular problem. Okay, now we are going to try to see intermediate value theorem. Okay, so let us look at intermediate value theorem. Intermediate value theorem. Okay, so let us see what it is, intermediate value theorem. Now I'll try to explain intermediate value theorem using an example. So and then I'm going to show you in a generic function. So let us take a function. Let's say I have a function of x which is equals negative 2x cube plus 4x plus 5. Okay, so this is my polynomial function. So what we need to show? We need to show that, that there is at least one real zero between x equal to 1 and x equal to 2. Okay, so we need to show that between x equal to 1 and x equal to 2 I have a real 0 for this particular given function. So what I am going to try to do is I am going to basically explain this using a graph. This is x, this is my y, and y is function of x, you all know that. Okay, so I have one point which is where I have x equal to 1. So here is my x equal to 1 point, and let's say here is my x equals 2 point. Okay, of course I basically at this point do not know the plot of the whole function. Okay, so but I do not need to know, I'll try to find only these 2 points. So first of all I'm going to try to find function of 1 and function of 2. So let us see, let's find out function of 1. So what is function of 1? Negative 2 1 cube plus 4 multiplied by 1 plus 5. So I got function of 1 equal to 7. Okay, this is my function of 1, which is actually equal to y. So for x equal to 1 I get y equal to 7. So this is my x equal to 1, y equal to 7. Okay, now let us find out function of 2. So what is function of 2? Okay, negative 2, and instead of x I'm going to write 2. So it is 2 cube plus 4 multiplied by, instead of x here I'm going to write 2 plus 5, and I found that's to be -3. So what I found, function of 2 equal to -3. So function of 2 is -3. So -3 is somewhere here. So this is my 2, -3 point. Now as you can see, function of 1 is +7 and function of 2 is -3. So my 1 point is above the x-axis, another point is below the x-axis. So both have opposite sign. Now we know what is the properties or property of any polynomial function. That polynomial function is what? Continuous. So this function must need to be continuous between this point 17 and this point 2, -3. So how you can draw a continuous function? It must need to cross what? That x-axis. Okay, and we know that this is what? A real 0. All right, so I can have at least 1. Now for the sake of argument, let me try to draw this graph again. Okay, the same graph. I am not going to. So I have my point here is what? 1, 7, and I have what? Another point which is 2, -3. So let's say 2, -3 is somewhere here. 2, -3 is somewhere here. Now as this polynomial function is continuous between these 2 points. So okay, in the previous case I have only one real 0. Now let us see. My graph could what? My graph could intersect more than 1 point. So I can have what? In this case I have 3 real zeros. Okay, so but I can say for 100% sure I must need to have at least 1 real 0. Okay, or I can have more than 1. So so we prove that for this particular function, or for this particular polynomial function, I have at least 1 real 0 between x equal to 1 and x equal to 2. So this is called intermediate value theorem. All right, so I hope you understand the intermediate value theorem. Okay, so let us try to solve some problem finding real 0 of a polynomial function. So just to recap, for here I did found real zeros of real zeros for 2 problem. Here is my problem, this problem, and here I have another problem we solved and we found real zeros. Now as you can see, for this function I found 3 real zeros, and for this problem I found only 1 real zeros. Okay, so now our objective is to, given a polynomial function, what could be the maximum number of real 0 I can get, okay, for a particular function. So real 0. So this is a, let's say, given a polynomial with degree n, so it's a nth degree polynomial, then the maximum number of real 0, number of real 0 is equal to n. Okay, so if I have a nth degree polynomial, then I can have at a maximum n real 0. Okay, I can have less than n. So but that's the maximum. Like for example, let's say I have a polynomial function of x equals, let's say, x cube minus x square plus x plus 2. So what is the n in this case? N in this case is 3. So for this particular polynomial, I can have as a maximum 3 real zeros, but after I solve, I might get even less than 3 polynomial, less than 3 real zeros, just telling. Okay, so maximum number of real zero possible for this problem is 3. So now let us try to solve some more problem. So let's say I have a function, a polynomial function of x equals x minus 1, x plus 2, x minus 3. Okay, we need to find the zeros of this polynomial. This is number 1, and so let's do this problem first. So I know that to find a real zero, I equate it using 0. So 0 equals what? X minus 1, x plus 2, x minus 3. Now first of all, let us try to find the degree of this polynomial function. Now you see here I have a x. Of course I am not counting for the saying that -1. Just count x here. Here I have a x. Here I have a x. So what I have, if I multiply x multiplied by this x, it's become x square, and then if I multiply with this x, I got x cube. So x cube is what? My maximum term. So what is my n? My n equal to 3. So this is what? A third degree polynomial function. Okay, this function is a third degree polynomial. So what are the maximum real zeros possible? So maximum real zero possible is 3. So let us see how many I got. So here I can write x minus 1 equals 0. I can write x plus 2 equals 0. I can write x minus 3 equals 0. So I got x equals 1, x equals -2, x equals 3. So what are my zeros of this polynomial? 1, -2, 3. So in total, how many real zeros I got? 3, and that's the maximum I got. Okay, so this is our first problem. All right, so let us now look at our second and third problem. So let's say second problem, let's find out the real zeros for this function gx equals x plus 1, x square plus 1. So this is my problem. Now first of all, let us try to find its degree. Okay, first of all, for now I'm not going to count positive one here. So let's count x and x square. So if I multiply x with x square, what I get? Again x cube. So that means this is what? A third degree polynomial. So n equals 3. So what's the maximum number of real zero possible? Maximum number of real zero possible is 3. So now let us see how many we got here. Okay, and we know that to find a real zero, I need to equate gx equal to 0. So 0 equals x plus 1 multiplied by x square plus 1. So now I have two mathematical expression in product form, and product is equals 0. So I can write x plus 1 equals 0 and or x square plus 1 equals 0. So I got here x equals -1, and here I got x square equals -1. I got x equals plus minus square root -1. So x equals plus minus I. Now as you can see, this is a imaginary number, so this is not a real. So how many real zeros I got here? 1. Okay, so for this particular problem I have only one real zero. So you see, I did not get the maximum for at least this case. I got actually in the previous case. Okay, so this is problem 2. So let us see now problem 3. Problem C. So let's find out real zeros for this problem. Hx equals x minus 3 square x plus 1. All right, so first of all let's find out the degree of a polynomial for this. Okay, n. So here let's see here, of course I'm not going to count, at least for this sake, -3 or -1. So let us see only the x. So I have here x, and what is the power of x? Power of x is 2, so x square. Okay, so I got x square here, so x square multiplied by x, so I get what? I got x cube. So that means again this is what? A third degree polynomial, and I can have maximum 3 real zeros. Okay, so let us see. So let's equate to 0 to find the real zero. So this is x minus 3 square multiplied by x plus 1. So I can write x minus 3 square equals 0, or x plus 1 is equals 0. So I can write x minus 3 equals 0. So x equals 3, and here I got x equals -1. So how many real zeros I got? I got 2 real zeros, and they are 3 and -1. So as you can see, although my polynomial is a third degree polynomial, it does not mean that I am going to get the maximum number of real zero. I might get less, and this case, as you can see, I got less, only 2 real zeros. Okay, so that's how we find real zeros. All right, so in the next video we will try to find a multiplicity of zero, turning point, number of turning point, those type of thing. Okay, so see you in the next video.